Rob Pincus here. I want to talk about how we discuss a bullet's effectiveness in terms of stopping a threat. We talk about defensive rounds. We used to talk a lot about handgun stopping power, right? This was a concept that you used to read about in all the magazines, the chat rooms, and the early internet. Lots of discussions on the ranges and in the gun shops about handgun stopping power. Really, they've gone away. We've replaced conversations about handgun stopping power and any attempt to accurately measure and predict what a bullet is going to do inside of a human threat with gel tests. Gel tests, very predictable, very controllable, also very easy to compare one bullet to another. The problem with gel is that it doesn't have the complexity of human anatomy and human physiology. So when we talk about the way a bullet is likely to perform inside of the human body and how good it's going to be at protecting us or stopping a threat, handgun stopping power has really gone away to be replaced with those gel tests, which are good but not great. And I want to talk to you today about this idea of dynamic shock index. What is dynamic shock index? Take a look at these videos. And what you just saw was an example of dynamic shock in action. You saw very large animals that are much tougher and stronger than the average human, obviously, being put down almost instantly by dynamic shock. Dynamic shock is the function of a bullet inside of the human system that not only disrupts anatomy, the cutting and the tearing and the pushing and the breaking, but also disrupts the physiology, the systems, the electrical, the nervous system, the cardiovascular system, because of the shock that goes through that animal or that human when the bullet enters the body. When we talk about dynamic shock index, the formula is MEPLAT, which sometimes seems esoteric, but is really pretty simple. It's the frontal surface area of a bullet. Whether it's a solid bullet or a hollow point, there is a measurable frontal surface area. If your bullet's pointed, you can't really get a true MEPLAT, and that's why the dynamic shock index really works best with flat front bullets or hollow points, and we want to start talking about accurate measurements. We want to take the MEPLAT, we're going to multiply it by impact velocity. Velocity is incredibly important, which brings us to the next part of the formula, minus 1500 minus the impact velocity. Why? Well, in the empirical tests, what we found is that 1500 feet per second as an impact velocity minimum is what's necessary to reliably create the kind of dynamic shock that you just saw in those videos and the kind of dynamic shock that's going to shut down your threat if you need to use one of these rounds in a defensive capacity. And then we're going to multiply that by sectional density. Sectional density is not just the weight of the bullet, but that's where the weight of the bullet is accounted for. And of course, that weight gives us the momentum. The sectional density, more specifically, gives us the momentum to continue depth of penetration and to maintain velocity while inside of the body. So when we look at dynamic shock index, we're going to take a look at a couple of rounds. Now, this dynamic shock index concept was developed by F.K. Brno. Of course, I've done a lot of work with F.K. Brno over the years. Their field pistol, their new polymer frame multi-caliber PSD pistol is designed around the 7.5 FK round. This is a very fast round. The original design specs were to emulate the terminal ballistics, the performance of the bullet at 100 meters from an AK-47, but to do it out of a pistol, and it does. Their newest bullet is the F9. It's a solid bullet with a flat front. Obviously, it's got a very high MEPLAT. It also has a relatively high sectional density, and it's moving very, very fast. When we run this round through the formula, we come out with an amazing number of 72.5 F5 on the dynamic shock index chart. Now, to give you an idea what that means, if you take a typical 44 Magnum round, the XT bullet, great bullet, you look at its MEPLAT, it's actually larger, obviously, in frontal surface area. 0.44 is definitely going to be larger than a 7.5 millimeter FK. It's moving fast, but not nearly as fast as the FK bullet. And of course, it has a higher sectional density, and we end up with a score of 50. It happens to come out to an even number, but that's a pretty good standard to establish, because when you think of 44 Magnum, you think of powerful rounds. The F5 bullet, which is a hollow point, it's a machined hollow point bullet from FK, 7.5 FK obviously, has a much smaller MEPLAT because it is a conical chopped off to a hollow point, moving a little bit faster because it's a little bit lighter, obviously less sectional density, and it still comes up almost to the classic 44 Magnum round. As you see, it definitely beats out the 357 Magnum, the F5 edges it out, the F9 almost doubles it. Much more powerful there. And then to look at some more traditional defensive rounds, the 10 millimeter auto, and of course standard gold dot 9 millimeter, 124 grain. That's a plus P velocity here at almost 1,300 feet per second. And obviously we've got a pretty good MEPLAT there, but we get less than 30 points on the dynamic shock index scale. And I promise you, if you want to take one of these 9 millimeter gold dots and try to take down one of those large wild boar that weigh in excess of 400 pounds, you're probably not going to see much success because it's a very low dynamic shock index. Now, what I want you to do is go over to fkbrno.com, look at the ballistic table. You're going to see some more comparisons with other bullets, and I want you to start running some of the bullets that you are interested in carrying, or maybe that you do carry today, through the dynamic shock index formula, and then compare it to real world examples, especially any examples you can find of their use in a defensive situation or in the hunting field where we're seeing real tissue, real living animals respond to what happens when a bullet enters the body. I'm proposing that dynamic shock index is a much better way to think about predicting how good a bullet is going to be at stopping a threat. And that's really what we want out of a defensive round or any round chosen by an armed professional.